Okay, welcome back, everybody. Welcome back. I hope everyone's doing well. And this is basically Unit 11 of our 12-unit school year, Unit 11, entitled Quadratics. Unit 10, by the way, was polynomials. And you always use the analogy of, you're really hungry and you want a Chipotle burrito. So Unit 10 was basically factoring and simplifying a bunch of polynomials, and that was all important. But Unit 11 is really the end game. That's really what we want. This is eating your burrito, walking through the front door of Chipotle and ordering your food and eating it, which you really, really want, right, to satisfy your hunger. So you can see here once again, I just snagged a bunch of Google images. You can just see these are all quadratics. So if you can follow this right here, it's a quadratic formula. We'll do that. The graph of a quadratic function right there, which is a u. It could be an upside down u, like this, like the arch in St. Louis, or it could be just a normal u, like this. And you can see we're factoring and solving. This is actually, you can pretty much learn most of this unit just by looking at this thing right here. So it's actually pretty cool the way this thing works. Okay, and I'll go over all this. And you can see that right here, if you can see this part, shooting a basketball, whatever goes up must come down. It has an arch to it. So we can figure out how long from the release point to when it swishes through the net. So lots of things we can do here. And when you get to calculus, you're going to be going to more in-depth things like this, finding the area under the curve or between the curves. So you can see where this has a lot of implications, not only for this year, but for years to come. So without further ado, let's get into it. Okay. Do you remember how important, if you remember how important y equals mx plus b was when you did lines and linears, this is every bit as important. This is the general equation for a quadratic. Anything that's a quadratic is squared. So if you see that squared right there, see that 2 that's squared, anything that's squared is a quadratic. So if you measure it up, here's your a would be 1 here, x squared plus b is 10, x plus c is the constant, okay, and equals 0. I'll talk about that in a second. This is what we did right here. I'm going to underline this right here. This is what we did in Unit 10. We took a polynomial or a trinomial like this and we factored it. So what I'll do is open up parentheses. And what we did is we put x and x in, and this was all important. This was all like driving to Chipotle. All this was important. And you found factors of 21, 2 plus signs, factors of 21 that add up to 10, 7, and 3. The order doesn't matter. And of course, you could FOIL check all this, and you know this is, excuse me, this is your answer. Now, this was all done in Unit 10 perfectly. What we're going to do in Unit 11 is just go our last step. So we're going to set it equal to 0, and we're going to solve. So we're going to use something called the zero product property. So I'm going to take x plus 7, just one thing at a time, just this part, x plus 7, and set it equal to 0. So what number plus 7 gives you 0? And that answer, and I'll put it up here in this little bracket thingy, is -7. There's your first solution, comma. And then I'm going to take, that part's done. Now I'm going to take x plus 3 and set it equal to 0. X plus 3 and set it equal to 0. And here's the same question. What number plus 3 gives you 0? And that, of course, is -3. So in my solution set, this is not an ordered pair, I have -7 and -3. Remember, this is not x comma y. These are two values of x that when I substitute them back in for x here, I'm going to end up with 0. We call these solutions or zeros or x-intercepts. We'll get to that later. Okay, that's basically quadratics in a nutshell, little foundation. Okay, now I talked about factoring and solving. We can also use the graphing calculator. Now, I didn't mention this before, sorry. For the rest of this video, you're going to need a graphing calculator. So go ahead and hit pause and find any graphing calculator because you're going to need it for the next couple things here. Okay, welcome back. Hopefully you have your graphing calculator in front of you. Here it is. Here's what we're going to do. I'm going to do this in two different ways. I'm going to factor this first. I bet you thought we were done with factoring. You're never really done with factoring. And what I'm going to do is I'm going to factor this, put x and x. I did this problem in class, but it doesn't hurt to see it again. Two positive signs, because everything's positive in the trinomial. And factors of 4 that add up to 5 are 4 and 1. Now remember, in Unit 10, we stopped right here. But now we're going to set it equal to 0, and we're going to solve. So what number plus 4 gives you 0? And that, of course, is -4. That's your first answer. And then what number plus 1 gives you 0? And that is -1. Now, you could do all of this on the graphing calculator. What I want you to do is go to y1, that key right there, y equals key right there on your calculator, and y1, type this whole thing in right here. X squared plus 5x plus 4. So put the whole thing in. X squared plus 5x plus 4. And then what I'd like you to do, please, is hit the graph key, and you're looking for the two x-intercepts. And I will bet you if you do this right that these are the two x-intercepts. It will look something like this. It will look something like this. Negative 1, 2, 3, 4. It'll look something like this. It'll cross at negative 4, and it will cross at negative 1. And remember, it's a u. All parabolas are u's. And you can see it crosses at negative 1 and crosses at negative 4. And those are what we call the x-intercepts. They're the same thing as the solutions. We also call them roots or zeros. More on that in a minute. Okay, let me erase what I have here. I'm going to just erase as I go sometimes with these videos just so it doesn't get too clogged up. So I'm going to erase this as I go. And let's do this one together. Let's factor this one. So open up your parentheses. And again, I'm writing this with my mouse, and I'm left-handed, so my writing is never great, but I'll do the best I can. So 2x's last term is negative, so opposite signs. Factors of 24 that when you subtract give you 5 are 8 and 3. We'll put them off to the bottom here. 8 is larger. That takes the sign of the middle, so 8 goes here. And then what's left is the 3. I started to write a 5. Is the 3 this here. Now, that was all Unit 10. And Unit 11, we're going to solve it. So we're going to set it equal to 0. What number plus 3 gives you 0? And that's negative 3. And then what number minus 8 gives you 0? And that, of course, is 8. So once again, on your graphing calculator, please go to y1 and type this right here. Right here where I'm underlining it. Go to y1 equals, and type that. Okay, don't worry about the equals 0. Just type that in, and then you're going to get negative 3, comma 8 for the two x-intercepts. X-intercepts. Okay, and we're gonna kind of put all this together at the very end. So I'm going a little fast, but I'm gonna recap all this in a few more slides. Okay, another thing in class. This one's a little rare on an SOL, but we're gonna solve these by hand. So what I'm gonna do is I'm gonna solve for S as in Sam. So I'm going to add 5, just like an equation. I'm going to move this 5 over by adding. So I'm going to get 2s squared. 2s squared equals 32. I'm going to divide both sides by 2. And I'm going to get s squared, s as in Sam, s squared equals 32 divided by 2, which is 16. Now, we want to solve for s. Don't divide by 2. It's s squared. Take the square root. So I'm going to take the square root of both sides. The square root of s squared is just s. Believe it or not, the square root of s squared is just s. The square root of 16 is 4. Now, there's two answers here, okay, because this is s squared. So s is going to take on two values. It's going to take on positive 4 and negative 4. Here's why. If you take 4 times 4, you're going to get 16. If you take negative 4 times negative 4, you're also going to get 16. So s is going to have two answers, positive 4 or negative 4. And we use this symbol here. That means positive or negative. So if I write this, for instance, this is going to be positive 10 and negative 10. This is two answers right here. Okay, let's do this one. I can squeeze this one in. I need to move the 54 over. And again, we've done all three of these in class, but just in case you need a little refresher, or you were absent, just watch this. Because when you're absent, I always say watch the video. So here it is. So 6x squared. I'm going to add 54 to the other side. I want to move the 54 over. So 6x squared equals 54. Now, neither one of these are perfect squares, but that's okay. I'm going to divide both sides by 6. Got to get rid of the 6. So you want x squared by itself. So x squared, these are gone, right, equals 9. Now, x is going to take on two answers. Don't divide it by 2. Take the square root. So x is going to be 3, obviously, because 3 times 3 is 9. But it's not just going to be 3, it's also going to be negative 3, because negative 3 times negative 3 is also positive 9. Okay. Let me do some erasing here. Let me do some erasing. Give me a second here. Alright, I want to show you one with a fraction, just in case you get something like this on an SOL. Fear not with a fraction. You know what to do with a fraction. Just invert it. Take its reciprocal. This, I believe, was a 32. I hand wrote it because the typing didn't come out. Okay, so I'm going to add 2. This one's got a lot of steps, so stay with me on this one. Let me back up for a second. I'm sorry. Let me back up. This was supposed to be a 30. Not a 3. It's supposed to be a 30. Okay, 30. So add 2. Add 2, add 2. I want this to be a perfect square. So you get 1/2 x squared equals 32. All I did was add 2. That's all I did. Add 2 to both sides. Now, I'm going to get rid of the 1/2. Don't divide it by 2. I'm going to multiply it by 2 because I want to take the reciprocal. So I'm going to multiply this by 2 and this by 2. So these are gone. So x squared is going to be equal to 64. Now, take the square root of 64. So we know that x, I'll put it up here, we know that x equals 8. We know it's positive 8. But x can not only be positive 8, x can also take on a negative 8. Because negative 8, see if I take negative 8 and I square it, remember it's in parentheses because it was squared, and square it, I'm going to get 64. See, negative 8 also works. So positive 8 and negative 8. Okay, let's kind of put this together real quick. Let me put this together. Here is just a sample question that I pulled from the notes. We might not have covered this one. In any case, it doesn't matter. And what I'm going to do is I'm going to factor this just like we did in Unit 10. X and x. Don't worry about the equal 0. In fact, pretend that's not even there. I'm going to cross it off. Factors of 15 that add up to 8. Very easy. 5 and 3. Put your 5 in here and 3 in here. The order doesn't matter. Okay, that was Unit 10. I can't stress this enough. The difference between Unit 5 or Unit 10 and Unit 11. So here's Unit 10. We factored this. That's all we did. In Unit 11, we're going to solve. It's equal to 0. So we're going to go all the way and get our two intercepts. What number plus 5 gives you 0? And of course, that's negative 5. What number plus 3 gives you 0? And of course, that's negative 3. Now, you can check this on your graphing calculator. Put this whole thing in y1 up top. Put this whole thing right here in your graphing calculator. Hit graph, and these are going to be the two x-intercepts. Well, it works out so well in Unit 11. Okay, if you know your vocabulary and you follow all the steps, it really kind of completes the whole circle. Okay, there's another way to get the two answers besides the graphing calculator and taking square roots and factoring and zero product property. We can use what's called the quadratic formula. And what we need is we need an A, a B, and a C. Now I'm going to warn you, we did this in class, but it's a lot of writing. It's not hard, but it's a lot of writing. We need an A, a B, and a C. Now remember, the A is the number in front of the quadratic, so that's 1. The B is the 5, and the C is the negative 36. Okay. And it has to be equal to 0, so everything needs to be on one side of the equation. Okay. If you had like a 5 here, you have to move it over first. We're going to use the quadratic formula, and that is derived from the quadratic equation. If you go back to the first slide, it was ax squared plus bx plus c equals 0. And somebody somewhere decided, just for fun, to solve this for x. And they did 8 steps, and they eventually got this formula here. So this formula in this little thing, this quadratic formula, here's the quadratic formula, is derived from this formula right here. So this formula right here eventually became this formula, believe it or not. And from this now, from a simple problem here, let's just pull out our A, B, and C, which we did, and let's plug everything in. So x, I want to solve for x, equals negative b, b is 5, so negative 5, plus or minus, be patient with this, there's a lot of writing and I got to write slow with this mouse. Inside the big radical we have b squared, b is 5, so 5 squared, b squared minus 4. All I'm doing is turning all the a's, b's, and c's up here into numbers. 4a, a is 1, and c is negative 36. These numbers will get big, but you have a calculator, so you're okay. All over 2a. A is 1, so 2 times 1. Okay, equals. I'm running out of room very quickly here, so I might have to just skip a step or two, but I'll go slow. Negative 5 plus or minus. Inside the radical, I'm going to have 25. I'm going to do it off to the side here. I'm going to have 25. Oh, there's no room. There's no room. I'll tell you what I'm doing. Let me erase this a little bit. Let me just erase this. inside the radical, I'm going to have 25 minus, you take all three of these numbers and multiply them together, you're going to get negative 144. Yeah, you really will. Double negatives, positives, so you're going to add these together, and you're going to get 169 in here. 169. On your calculator, that's going to be 13. All over 2. Okay? Underneath all this, I'm going to get 169. So I'm going to have negative 5 plus or minus 13. The square root of 169 is 13 all over 2. So, and I'll use red now so you can see the answers. The way we're going to write it is negative 5 plus 13. Start with the plus. Start on top. Plus 13 over 2. That's one answer. And then I'm going to have negative 5, you guessed it, minus 13 over 2. Now, what's that going to give me? Negative 5 plus 13 is 8. So I'm going to have 8 over 2. That's going to become 8 over 2. So my first answer in the funky looking bracket, I'll put it in red, is 4, comma. Remember, the order doesn't matter here. This is not x and y. Okay, down here, this is negative 18 divided by 2, which is negative 9. So here are your two solutions to this formula, to this equation. Using the quadratic formula, these are the two solutions. Now, if you put this in your graphing calculator and go to y1, type this in your graphing calculator, you don't need this, you're going to get these two x-intercepts. And it works out great. I need you to know the quadratic formula, though. You're going to see this on your formula sheet on the SOL, and we simply need to know how to do it. It will be as part of the open note quiz coming up soon. Okay, a couple more slides here real quick. All right, one of the last things we'll do in this unit is called the curve of best fit. Now, we've done the line of best fit, and we will review the line of best fit in class, because I know we forgot all that stuff. It's basically the calculator does everything for you. So you need your calculator on, so turn your calculator on, and here are the directions. All you need to do, and I can't really do much for you right now because I don't have the calculator screen. What I want you to do is on your calculator in stat, hit the stat key, and actually, I'm doing this with you right now. So I got my calculator with me. I'm going to hit the stat key, and I'm going to hit enter, and I'm going to put all of the x's into L1. So go to list 1, L1 on your calculator, and type this whole row in, 1, 3, 5, 7, 9, 11, 13. Okay? Once you're done with that, go to list 2, and type in all the y values. So you have L1 and L2. We've done this before. You should be able to do this. And I'll wait for you. Go ahead and pause the video while you're doing that. Just hit pause, please. Okay, we're back. You've got all the data in. Here's what you're going to do. All the data is in. The calculator's going to do it for you. Hit the stat key on your calculator. Hit the stat key towards the top. And use the right arrow key and arrow over to calc. And then hit enter. And you're going to want to hit the stat key, hit calc, and sorry, don't hit enter, hit the calc key, go over to the calc key and hit 5 for quad reg. Quad means quadratic regression, and enter twice. Hit enter twice, and you're going to see this. You're going to see A equals, if you did this right, you're going to see A equals 5.25. I'm going to do some rounding here. B is going to be 67.2. And C is negative 81. If you're not getting these numbers, check your data. Make sure you put everything in the right way. 81, negative 81.5. Round it up. Now, if you remember, your original quadratic equation is ax squared plus bx plus c. And all you're doing now is substituting everything back in. Remember, for the quadratic formula, you pulled stuff apart to get a, b, and c. Now you're going to put it back in. So a is 5.25. So we're going to write it as 5.25 x squared plus b, but b is 67.2. Don't forget the x. Don't forget that x. And then c is negative 81.5. So just go to minus 81.5. Now, this is important because what they might do is they might give you a list of data and they might say, well, what about 10? Where would data point 10 go? See, there's no 10 on this. So what you would do is you would take the 10 and plug it in for every x. Do the math, and you would get your corresponding y value right here. I hope that makes sense. They might, okay, in other words, let's do it for 2. See, this is 1, 3, 5, 7, 9. They might say, what would it be for 2? So you take the 2, remember 2 is your x, and you plug it in for every x that you see here, and then do the math. It's a bit tedious, but it's not very hard. You should be fine. Okay. I promise to keep this video kind of short, so let's kind of put it all together here real quick. Let's just put this whole thing together. Here's another problem from Unit 10, and what I'm going to do is I'm going to factor this. So I'm going to go 2 parentheses. This is basically my last slide, so stay with me. X and x, opposite signs. Factors of 28 that when you subtract give you 3 are 7 and 4. 7's larger, 7 goes here, and 4 goes here. You can hit the pause button if I did this fast and you want to look at it again. You hit the pause button. Okay, now, what we did now is we took the entire answer from Unit 10, and we're going to set it equal to 0. And we're going to use the 0 product property. Product means multiplication, so we have to get 0 when we multiply these. We're going to set it equal to 0. So this is that. What number when you add 7 gives you 0, and that's negative 7. Okay, this is what number when you subtract 4 gives you 0, and that, of course, is 4. Now, let's check this on the graphing calculator. I want you to go to y1, and I want you to put the whole thing in, x squared plus 3x minus 28. You can put that in. By the way, you can also put this one in instead, because this thing right here is the same thing as this. So you can go to y1 and actually put this in. It's just kind of tedious because you got a bunch of parentheses. So that's your call. You can put this one in or this one, get the same answer. Find the x-intercepts, and I guarantee you, if you did it right, you've got negative 7, 4 as your 2 solutions. Okay, verify this by the quadratic formula. Okay, so a is 1, so we know that a equals 1. We know that b equals 3. And we know that c equals negative 28. Let me do this one real fast for you. I'm going to erase all this because I'm going to need a lot of room. Basically, our last problem in the video. Here it is, here it is, here it is. Stay with me. And here it is. Okay, so negative b, so negative 3. I'm going to do it kind of fast. Plus or minus. If you're just washing, that's fine. 3 squared minus 4 times a times c. You will get this formula on your formula sheet. So if you get a problem like this on the SOL, and most people will just use the graphing calculator anyway. They won't use the quadratic formula. But I just want to show you how to use it. And then 2 times 1. Okay, let me do this fast. So negative 3 plus or minus. Inside the radical, we're going to have 9. I've got a double negative here. So minus 112. 4 times 1 times 28 is 112. Is that right? Yep. Okay, now double negative is positive all over 2. So what I'm going to have now is negative 3 plus or minus the square root of 121. 9 plus 112 is 121 all over 2. Well, you know the square root of 121 is 11. You should by now. So negative 3 plus or minus 11 all over 2. So to get my answers, I'm going to go, let me use red, is negative 3 plus 11 over 2. Now that's 8 over 2, which is 4. Ta-da! That was one of our answers, right? And then negative 3 minus 11 over 2, which is negative 14 divided by 2, which is negative 7, which is the exact same answer we got up here. It's great how it all works. It really is. Okay, final thing I want you to know is zerks. Don't forget zerks. Z is zeros. These all mean the same thing. These all mean the same thing. So if you find the zeros, you're actually finding the roots. If you find the roots of the quadratic, you're also finding the x-intercept. I'm just going to go int. And of course, if you're finding all three of these, you're finding the solutions. Bring your questions to me in class. We will have an open note quiz coming up soon. And of course, there'll be a Unit 11 review sheet coming at you in a couple of weeks. Okay, I hope this has been beneficial to you. As always, I hope this has been beneficial to you. I'm sure it will be.